Well, good morning, everybody. It's 9 o'clock. We're going to get started. It's a beautiful day in Chicago. Everybody happy to be back at RSNA with normal crowds. Doesn't it feel like pre-COVID, right? It's like a real pleasure to see the real crowds of RSNA from pre-COVID. So welcome to this session. I'm Florent Saint-Clair with Dicom Systems. I'm joined by my colleagues Mark Dobbs from Pure Storage and Matt Hayes from Rad Partners. Most of you, I think, will be familiar with our organizations, but this is not about our companies. This is about an educational session, and we're going to be talking about some, we think, very important aspects of running enterprise imaging organizations. There's a human emotion that we've noticed has actually taken over our industry for the past few years, and it's called FOMO. I think most of you know what FOMO means, right? And I do mean FOMO, not, don't invert those syllables, because that could mean something else. So what we think is going on in the industry is that every so often there's something fundamental that comes into the marketplace, a new technology. 10, 15 years ago, it was cloud, right? When we started talking about image sharing in the cloud in 2008, 2009, cloud was barely known by anybody, right? So everybody was like, what's the cloud? Well, it took a lot of years of education before a lot of us in the industry started feeling comfortable about putting data in the cloud and trusting cloud companies that we did not control, that we outsourced to with our data, especially PHI and PII. And then a few years later, you've got this AI tsunami going on, right? And there's a lot of hype going on, a lot of cloud hype, a lot of AI hype. And so what this session is about is taking a step back, thinking for a minute, right? Don't give in to the hype. We're all very rational individuals for the most part, right? Unless time of day. But it's very important for us to not give in to the hype. And so what we're going to be covering in this session today is, if you must use cloud, and you probably do, if you must use AI, and you probably do already, what are some of the things you need to do to ensure that you're placing something clinically relevant into production, that you're not messing with your physician's workflows, that you're not adding latency to workflows, and that even more importantly, you're not adding some kind of security threat, cybersecurity threat specifically, into your workflows, because there are so many algorithms. How do you entrust the reviewing of the security side of all those algorithms? So if you could go to the next slide, please. So the first thing we're going to do is, and thank you, Matt, for being here. We're going to be evaluating, what does an organization like Rad Partners do to evaluate a cloud solution, or even, use cloud in the first place. It's almost inevitable that we're going to be using cloud. So what do we need to do to ensure safety of our operations? We're also going to be looking at 10 specific rules for what it takes to safely place some kind of AI into production. Now, some of you might say, well, we've already been using AI for a number of years. It's kind of a non-issue for us, but it's not a non-issue for a lot of people, right? Some practices have not even implemented their first algorithm. They're still using a lot of older technology that is not geared for AI. And then finally, we're going to look at the cybersecurity impact of cloud and AI on your operations. So let's go.
Yeah, so thank you guys again for being here.
Yep.
Just to add a little levity to the room, to the session. Good morning again. My name is Mark Dobbs. I'm a peer and fellow counterpart with Florent and team. I work at Pure Storage, but my background is all based on enterprise imaging. So I've kind of been in the consulting roles there for a long time. And as Florent said, we've seen cloud obviously has been here for a long time. All of us are probably Gmail users, so we're all users personally. And it's a great thing. It's a great tool in many cases, and it's really good at a lot of different things. Obviously, it's changing the market for us in the medical space. But as we know, healthcare is a little bit perhaps risk adverse. I think a lot of us don't want to be the bleeding edge when it comes to adopting new technology, or maybe we do that in a controlled manner. But as we kind of look at cloud, as Florent had mentioned, it's still something that we're learning from, at least in the enterprise imaging world. We're going to dive into that a little bit deeper for maybe why it's not just this mass adopted, we're all just reading everything remotely from the cloud. Obviously, COVID's changed things where a lot of us went to reading remotely. And perhaps that was, a good spark of evaluating if cloud is a great solution for you. Many of you may be also wondering what exactly is the definition of cloud. So in this sense, we're more talking about the bigger names of the cloud, right? So the Googles, the AWS, and the Azures. But as you know, cloud also comes in many flavors and forms. People have private cloud settings, and if you're reading remotely from a data center that's not in your home or not in your hospital, you could also consider that part of your private cloud in many regards. But again, just a little levity here. We've been hearing about it for many years, since 2008 or sooner, and we're still learning, right, from it, what's going to work best for you. And let's go into the next slide and kind of unpack more realistically, though, where organizations have to navigate the kind of workflow, right? So I think everything that Florent mentioned before we make any change, it's very common for us to engage with customers, and we'll speak with, say, the IT side of the house, and they're making decisions based on maybe economics, and that's where they're evaluating whether or not cloud's a good fit for them. And what's missing is the clinical review. It's very common, unfortunately, for us to get into conversations whereby there are decisions being made maybe just for the market trend, and they're not necessarily fully realizing the impact on the clinical side. And so the small takeaway there is that the last thing we want to do is remove or add steps to a radiologist. I don't want to make you any slower. In fact, if anything I do, it should make you always faster or give you more capability. And so to start evaluating that's like, in our opinion, mission number one. We need to identify the clinical workflow. Many of us have different flavors of PACS systems or VNA systems that have short-term cache amounts, and our organization has decided how much data we want living in a very small pool of very fast accessible data. But we've made those decisions based on a number of factors: what my mammographers want to read with, what the latency looks like between all of my remote reading facilities, how the data gets to us, what the technologists need to do. There's so many steps, as we all know, on the clinical side that have to be accounted for and mapped out before we can really even think about evaluating or adopting any new technology. And Matt's going to talk about that a little later, but we're also bound by, and this isn't a bad thing, we're not shackled by this, but we're bound by the standards of HL7 and FHIR and Dicom. And those are great adoptions that we have in this space, but they also come inherently with their own challenges. HL7 data, that's our messaging data, our order data. It's obviously a very lightweight piece of communication. And what can happen sometimes is it can race down, say, the freeway to get to the server or the cloud, and it beats those images. So think about that. That can be a mismatch of data where all of a sudden we have the order arriving before we have the images, and maybe sometimes the technologists make clinical changes to the things like patient demographics or submit additional views. That HL7 data and that order data can arrive beforehand. There can be mismatches. So again, these standards are something that we're going to be not stuck with. It's not a bad thing, but it's something that we always have to appreciate and be bound by as we evaluate where we're going to move technology, because we don't want to break or sever the communication gap there. Which leads us to, obviously, faster. We all want faster, and we all need more. And many of you that may have read from home recently or have been reading from home, we always go out and get the fastest internet connection possible, all right? Because faster is generally better. Same thing happens if you're going to lead more into a cloud-native deployment. You want to then, at that point, really make sure that you have dedicated connections for your organization to feed the data to the cloud and then be able to propel it back down to you, the reading workstation. But that introduces another step of overhead and costs that are often understood by organizations when they're moving to the cloud. They don't necessarily realize all the other implications that may come with it. which are things like dedicated connections to, say, your provided cloud provider. And those can add significant costs per month. You also have to contract your local service provider for where your hospital or organization sits to be able to connect into that. And that may also introduce additional costs. So again, good things just to keep factoring in, but we want to make sure we're as fast as possible for communication, especially because we're bound by these, Dicom and HL7 standards. And I think it's all for naught. Like we all know, I think it's no secret that AI, FOMO is the word we use, but we need help. I think all of us will agree that we would want to have aids now. The AI is no longer seen necessarily as a threat, thankfully. AI is definitely well adopted. It's still maybe in the crawl walk phase. It's probably in the crawl, maybe the walk phase. Obviously we do have FDA and CPT codes that are approved for some vendors out there for algorithms. But when we do that, when we start unleashing more of these, flash forward 5 years or 10 years from now, we may have 15, 20 different algorithms, not just running in the imaging pool analysis, but many steps along the way, the clinical journey of the patient, that feasts off data. We have an organization that one algorithm looks at 20,000 exams in 1 hour. And they had to time that algorithm to pre-screen all of those exams that it would process through. And they had a stage at a time of like 3 or 4 in the morning because it was actually consuming so much bandwidth and so much data that during normal reading hours, the radiologists were finding that there was a lot of latency. Things were slowing down because that AI algorithm was just pulling data much faster than they were obviously as a human level. So we need to realize kind of what are the impacts that AI, which is well needed, will have on how it consumes data. And again, where does our data need to live? And last, it's all for naught if we can't, be secure and be safe. Florent will touch base on this a little bit later, and Matt. But unfortunately, the invisible, enemy in the room is, of course, these bad actors. Matt has a more appropriate word for it, but it's
not presentation appropriate.
Not presentation appropriate, but those are factors that unfortunately are threatening us, and they're invisible. They may strike at any time. It's definitely a matter of when, not if. So there's ways we need to evaluate how we kind of navigate that data movement, where the data needs to live, and then how to really wrap around data protection. So next slide, please. So to kind of unpack it a little bit more, if you were to evaluate where your data needs to live and say you're considering moving into the cloud, kind of the 4 tenets that a lot of customers usually race towards for making decisions, and Matt, feel free to step in here.
No, absolutely. There's several considerations that any organization, any practice is going to undertake when making the decision to do that. In fact, the implementation deployment of the cloud present day is very similar to, I remember, the race to PACS in the early aughts. It was no longer a boutique technology of the late 90s that only the expensive places could afford, but now it started becoming a lot more apparent that was a path of applications for the future. There's a lot of different reasons that a lot of different people make the choices to do that, and some of them are up here. Do I need better disaster recovery? Do I need better failover security? Am I outgrowing my facility? Is the broom closet I have my PACS server in not big enough that I need 2 broom closets, or are we changing locations and need to move our data accordingly with us and our hardware? It's a very personalized decision. Everybody's got the reason. One of the biggest pitfalls at the beginning of the process of going in there is doing it because everybody else is doing it. Well, I have to do it because everybody else is doing it, and you make that knee-jerk reaction, trying to go with the enterprise imaging herd just to feel that you need to keep up. It's a transition phase. It doesn't happen instantly. It does not happen overnight, just due to the amount of work that's involved. Keeping that in mind, what will help stave off a lot of the anxiety is having a great understanding of what your workflows are, and on top of it, what your corresponding data flows are. So you make sure as you're transitioning over, things are more smooth. Our data flows need to live on top of our workflows, because the workflows is where all of our clinicians, our diagnosticians live. That's where the work is getting done, the results are being generated, and patient care is being delivered. Once you do that, and then you kind of frame it out here, it's like, well, we need to grow, we need to scale. We're adding on 20 outpatient imaging centers, 10 of which are going to be doing breast tomosynthesis. We got to store it, but more importantly, we need to move it across town, across the county, across the state, and maybe even across the country, where our reading and interpretation is having. So knowing all of those bits in the chain between your radiologist's eyeballs all the way to the electrons that the information is being etched into on the disc will help craft your decisions and help guide you towards what's appropriate for your situation. Here, before I get the next slide. And here, this one I'm going to stand up for because this is, I've got a lot of pet peeves here that I just want to air out. There's a lot of different things you need, the self-assessment that goes into the process that you have to encounter when doing it. I already warned you, just don't do it because everybody else is doing it. Have a plan, have a goal. Why are we doing this? What problems are we trying to solve? Once you understand what your problems are, you can apply appropriate measurements against that. Get a great baseline, understanding where your gaps are, and then being able to try even in the mad dash to the end that we all subsequently land up taking, that we have a way to tell that we were successful in doing it. One of the biggest takeaways here, especially with your data flows and your workflows, if there's any technical takeaway that I want you to leave with today, it's understanding the fact that latency kills. And we talked about Rad's teleradiologist saying it's like, oh, I've got 5 Fios or Google Fiber trunks running into my house. I've got like 8 gigabits. Why is this Tomo taking me 30 minutes to load? Because that last mile fiber delivery is just one segment all the way up to the display, all the way back to the disk, as I mentioned before, and everything else that happens in between. At scale, you have to understand how your infrastructure interplays with your service delivery. Sometimes I'm at the mercy of the internet as much as anybody else. Some of the Netflixes and the Amazon Primes of the world have a little bit more funky ways they can do that, but based on how they're distributed and some of the algorithms they're allowed to do. But based on the diagnostic quality requirements we have with PACS, we don't have all the funky compression options at our disposal. So we have our tool sets that are well known, but we have to cater against. And with the latency, it's not only network latency, but now we get to the point where we have to consider infrastructure latency. How long does it take to write to a database table? How long does that write formulate against a run to your storage layer? How does the application layer work with your data layer, working with your storage layer, your compute, your store? All of these things, as you scale, become very, very, very important. Where you can tolerate a 1 millisecond delay when you're reading 10 studies a day versus trying to tolerate a 1 millisecond reading 100,000 studies a day or moving 100,000 studies a day, those things add up and multiply. So understand where your gaps are, understand where your opportunities are, and if there's a technology solution that needs to be deployed either on-prem or taking advantage of any of the features, functionalities that the various cloud vendors have to offer, get them aligned with your goals and your measurements.
You know, Matt, you just mentioned the relativity of speeds along a network. I think we should have included 5G in the hype, honestly. Because very few people understand what 5G actually means to them. You know, it's being billed as a major business solution, when really you're just improving speeds or the number of devices that a particular cell tower can handle, which means, you know, you go from 10,000 users to 1 million users on one cell. That's going to have an impact on your bandwidth.
Starlink.
And
all the early adopters of Starlink, oh, this is great. I'm in the middle of the woods and I have like 150 megabits down, and then all of a sudden more people get on. Then it's 120, then it's 100, and it's a technology limitation of the medium. So it's once again understanding what's involved in the chain.
Yep. Let's go to the next slide, please. So. The question whether or not AI is needed, I think at this point it's more a matter of when something is going to be deployed in your organization, right? There's so many companies, there's so many VCs and private equity groups throwing a lot of money into AI. It's an inevitable fact that you're going to have some AI running in your workflows. You probably already do. Actually, a lot of people that were doing mammography CAD a long time ago, now we call it AI, but that's what it was already, right? A lot of machine learning going into mammography. So there are quite a few pitfalls for AI in healthcare. Number one, you're dealing with privacy issues, right? How do all these companies train those algorithms? There's a whole sub-industry that's been created to feed these millions and millions of images into these algorithms. I think it was a Google study that mentioned that for an algorithm to reliably learn one thing, it would take 100,000 similar images, right, for that algorithm to reliably recognize what it's looking at. So you multiply that by the number of algorithms that are out there, the billions of images that need to be de-identified meticulously before they can be absorbed into an algorithm. A lot of other industries don't have that problem, right? The privacy issue has to be solved. And so where is the best place to do this? Well, one of the reasons that Google and AWS and Azure and now Oracle, Oracle is running a little behind but is actually catching up, is that cloud computing made a big difference for all these AI vendors to be able to afford to develop those algorithms in the first place, right? All the computing power that they couldn't afford as a startup company because they couldn't just train all these millions of images into an algorithm on a laptop. It was very convenient to train those algorithms in the cloud. But here's the problem now. You have your algorithms available as a cloud service only. That's one of the biggest issues, right? What if I need to bring this on-prem? What if I have some security policies that prevent me from using cloud for this? So let's go to the next slide, please. So how are we as an industry going to handle this tsunami? And it is a tsunami, right? I mean, you go through this exhibit hall, I mean, you just can't walk anywhere without seeing AI somewhere, AI something. I prefer to call it machine learning because that's really what it is, right? Let me not go into the, the psychosomatic aspects of AI. Let's go to the next slide, please. So these are the precepts that we think are the most important to think about. There's obviously some other ones to think about, but these, in our experience for the past few years dealing with AI, are the key ones to pay attention to. Number one, are the algorithms clinically relevant? In a lot of cases, it's IT people or security people who are left to their own devices to vet these algorithms, and the physicians, in some cases, have been left out of the decision to adopt some AI, right? This is how the rise of AI marketplaces have put a lot of noise in the industry, because you've got marketplaces that are aggregating algorithms that may or may not be clinically relevant to you. So the algorithms need to be clinically relevant. It can't be just some PhD student's pet project in grad school. It has to be something that a physician said, yes, I need that, I can use it, and it will improve my workflow. Number two, when these algorithms are being built, they don't always listen to the perspective of the clinician who's expected to rely on this algorithm, right? So involve physicians into that process. So when you're evaluating an AI algorithm, you need to ask, who contributed to this intellectual property? Did they think about the problem of bias in the data sets that went into training this algorithm, right? Bias is a big issue. In a lot of cases, these algorithms were trained with too few images just to prove that it could do something. You used a cohort that was too small and not diverse enough. That is going to build in bias right then and there. Then you get into workflow considerations. Matt just finished talking about the importance of knowing your workflow. Where in the workflow is this algorithm going to fit? Do the AI companies that build these algorithms Do they know? Do they know that workflow? Do they have a workflow specialist working with them in product management to know where is it upstream? Is it downstream? Where in the spectrum of the diagnostician's work does that algorithm fit? Because depending on where you put it, you're going to be either improving the workflow or making it worse by introducing latency into the process. Number 4, super important and often disregarded by companies that don't know Dicom, don't know HL7, don't know our industries, right? We have a lot of data scientists that are very good at building algorithms, but they're not healthcare people, they're definitely not imaging people, and therefore they'll train an algorithm not even knowing how to spell Dicom, right? They'll come to you and say, I've built this amazing algorithm, it's 99% efficient, right? More closer to 90% probably. But the problem is they're disregarding the wealth of data that is available in the metadata that goes with the image, right? Dicom is a bunch of headers, so it's information about that image that they are not taking into account when they're training the algorithm. Yeah. We already talked about bias, but there are a number of considerations when thinking about bias. It's a very complex problem. There are whole organizations dedicated to thinking about the various aspects of bias. I'll give you a quick example of how bias can make itself into a product. I think it's in the 50s or in the 60s that the seat belt was becoming a really important safety device in cars. And there is an issue of bias that was introduced because in the 60s, I think it was, all the engineers were male. And when they designed their safety belts for cars, they didn't take into account that, well, there's also female passengers, and that the seatbelt needed to be designed in a way that wouldn't potentially injure somebody who's not male. Well, that kind of design flaw can make itself into an AI algorithm as well, right? Blind spots. What are you not thinking about when you're training this algorithm that is now going to be really critical to diagnosing a patient? Another one that is really often not considered, especially by the marketplaces, these algorithm companies are all startups. Well, many of them are, right? If they haven't been acquired by a larger company, they are startups, and they are burning through cash. So let's say they built a great algorithm that makes it into a marketplace that your healthcare organization is now adopting. And then they run out of cash because they didn't have a viable business model. They didn't know who was going to pay for this algorithm, how much it was going to be paid for, right? And they run out of money. And now you have this algorithm in production doing something good for your organization, but it goes away because it ran out of money. All of these algorithms that are in marketplaces or come to you directly, they have to have a business model. It has to be viable. Then, one of the 10 commandments really, don't introduce latency. Latency can happen at any point of this workflow. And especially if you have to ship data to the cloud, de-identify it first, then wait for the result back, and then where is that result actually going, right? How are you consuming that result? All of these considerations can be lethal to the process and can either make or break a workflow.
Right, especially if your image storage is not near your algorithm, so you're either in data center A and cloud provider B where the vendor has their setup, and you're shipping images, de-identifying, processing, takes time, great, fine. It'll kick a result on, but if it's a stroke study, you're waiting for some sort of perfusion analysis, and it comes 2.5 hours later, you already blew your base stroke SLA. Does nobody any good. You're late. So understanding the workflows, when does this result need to be in front of the person making the decision, designed correctly?
Yep. Actually, I learned a new one yesterday from an AI company that why it's so important to have the physicians involved. So an algorithm was built to detect PE, right?
Right.
And they were doing everything with pulmonary CTs, like CTs of the chest, disregarding the fact that if they actually had trained the algorithm also looking at pelvis and abdomen, you have the lower part of the...
And you got to watch those lung bases.
Yeah. So the algorithm was actually trained disregarding a very important part of the lung, which is the lower part, right? So number 8, this should be obvious, but be more accurate or as accurate as a human. Physicians make mistake. That's why there's malpractice insurance out there. It happens, right? I think it's an accepted number that out of 100 cases they read, a physician may make up to 4 errors that could be pretty serious. So make sure your algorithm is at least as efficient as a physician, a human, or don't even bother, right? You want this algorithm to actually augment the capabilities of the physician, not try to catch up to the physicians. Okay, generating and distributing usable results. Here's the problem. These algorithms all have a different type of output. The output could be a Dicom structured report. That structured report needs to go pre-populate data in a report, right? So that's how you need to actually orchestrate that result. The result could be a presentation state. It could be a new Dicom object that needs to be added to the images. Well, what is the mechanism you're going to use to now integrate that new object or that new presentation state in the data set and make sure it's the same study instance UID, same accession number, all of that? That's an orchestration problem. The AI companies are not equipped to know the distinction between an accession number and a study instance UID and all of those things that we deal with every day, right? Another type of result could be FHIR. Well, what if you have one vendor that speaks FHIR and the other one that doesn't? Now you also have to translate FHIR to HL7 just to be able to distribute that result. All of these workflow considerations have to be figured out before you go into production with an algorithm. And then, last but not least, and this goes back to cloud, if an algorithm is only available in the cloud, you're going to have to do de-identification. You're going to have to wait for results to be produced in the cloud. You might be finished reading before a critical result comes back from the cloud or a red flag that the algorithms want to make you aware of as a physician. So there's an issue of orchestration every step of the way. We need to think about that when we evaluate AI. Let's go to the next slide. Which brings us to cybersecurity. So there's probably not a week that goes by without us hearing about some kind of cybersecurity event. A lot of the CIOs and CISOs in our lives are pulling their hair out because these are the things that all of our users need to use. Getting into an organization as a legitimate user uses currently a combination of, or at least one or two of these methodologies. It's something you are, it's something you have, or it's something that you know, right? It's a password, it's a PIN. Maybe you're on an LDAP, maybe you're in an LDAP domain, and you need to authenticate with both a password and a token. All of these things can, well, maybe not the iris scans. I don't think we're in the 22nd century yet, but these things can be spoofed. A bad actor can get a hold of a password, can get a hold of a PIN. Employees of organizations disgruntled because they were fired. There's so many things that can happen in an organization, whether it's the AI company building the algorithms or the healthcare companies using the algorithms. There are bad actors out there, and it's being proven to us every week. Let's go to the next slide. So here's the fundamental problem. When you get in, it's a pass-fail. You're either in or you're out, right? You enter your password, you have unfettered access to all the systems that you typically have access to, unless you have some user groups with very specific rights that are managed by an administrator. When you're in, you're in. So let's say somebody got a hold of your password and is in, there's no way for the system to distinguish between a bad actor and a good actor because they're in, they had the password, they're in. So what we're seeing is there's going to be an evolution in how security is done in healthcare organizations. And that is because these hackers are playing this game every day. It's actually a very relentless and empirical process they go through. There are known vulnerabilities that keep getting exploited because not all hospitals know everything all the time. Maybe they're not using the right cybersecurity standards, and they're still vulnerable to a vulnerability that appeared 5 years ago. And then there's all the new ones. Every day they're playing a game of Battleship and finding out what are those vulnerabilities in your healthcare organization's infrastructure. And it could be some weak database in a system that you just adopted. It could be some old vulnerability that wasn't ever patched by the vendor. All of these things happen every single day. And so what we're seeing is that there's going to be an increased amount of AI also on the cybersecurity side. Just like an algorithm is much better at a human at going through millions and millions of images and detecting something than the human eye, the same thing can happen in a user's behavior on a network, right? So for better or for worse, some people may call it Big Brother, but we are going to be seeing more and more complete and constant scrutiny of everything we do online when we're at work. What are some of the things, what are the systems that we access routinely and legitimately? Does this user go to Amazon at least once a day to go grocery shopping? Those things form a digital footprint. A physician has a digital footprint in the hospital. A registered nurse has a digital footprint. An IT guy, Matt, has a digital footprint. We all have a digital footprint. That constitutes the bell curve of our behavior every day online. And there's going to be more and more algorithms looking at that and making sure that if there's a behavior that deviates from this bell curve, that it's going to be red flagged. And maybe it's going to downgrade your user experience and say, wait a minute, re-authenticate. We don't know who you are. You're doing something you've never done before, and this algorithm is here to protect the organization. Right, so you're going to see more and more of that. It hasn't happened really yet because people are still evaluating what AI means to them and how relevant it is to their organizations. But you're going to see more and more of this. It's just if you're legitimately using a network, you don't have anything to worry about. But if you're a bad actor, you want them to get caught. And so the only way we're going to do that reliably, humans can't do it. You have to rely more and more on AI to look at human behavior in the online footprint.
Yeah, actually, Florent brought up a good point, but something that's maybe a bit of a misconception or unknown is if your organization generates the medical imaging data, the PHI, it's fully your onus, your responsibility for that data. So if you do just fling it to another data center to make it somebody else's problem to protect that data, it's a misconception. Meaning, we've seen, many years ago, iCloud was hacked, a lot of celebrities' information and photos were leaked, right? So eventually, and hope it never happens, but everybody eventually is going to fall victim to some breach, including the large hyperscalers, the big cloud providers, and private. Everybody's going to be victim to it at some point. And in the healthcare sense, it's really unfortunate because the onus falls back on the organization. But you're a little bit in a rock and a hard place because, and Matt can attest to this, a lot of the applications that we rely on today, the PACS vendors, enterprise imaging vendors, they're very much older legacy-based applications. They're not necessarily cloud-native applications to take advantage of all the beautiful things that a cloud can provide. So why do I bring that up as it relates to ransomware or this game of people locking up your data? Well, those systems inherently carry a lot of vulnerabilities. Dicom standards, the way that it communicates to storage, no matter where it sits, those applications have a lot of open doors that people can very easily slip into. And it's in that regard where, the evolution of not only just protecting your data has to, advance, and AI algorithms have to be there to capture breaches and bad actors. It's also got to be that the applications themselves as well.
Yeah. I also like to point out in the interdependency of healthcare IT, our current landscape, where we are in 2022, it's never just one facility or one organization. Everybody they're affiliated with, and then everybody we can get into a little bit of a discussion, how many nth degree what it is, but I will tell you one thing's for sure. Most security ops, network security ops and operational centers have really twitchy trigger fingers to kill connections these days based on how frequently these are happening with partners and affiliates. It's like, do we have any relationship with whatever happened over here? And it's like, it's either yes or no. If it's like, well, indirectly, boom, whack. Risk tolerance, 0. So, between the once you're in kind of methodology and knowing that, many places have legacy technologies that have known vulnerabilities and that we're still waiting for vendors to patch. You got a lot of twitchy people around saying, oh, nope. And understandably, because one interruption in one area can cause a lot of conflicts unintentionally elsewhere. So once again, understanding your data flows, workflows, where everything goes and where you're spreading things, anonymizing cloud vendors, whatever, please understand your setups.
I mean, literally to the point of there's some hospitals out there that are operating right now with old legacy PACS vendors that shall remain nameless, that are actually storing the usernames and passwords in plain text. In the way that they communicate to the storage array. They don't do that. No. Nobody does that, right? Nobody does that, but that's a very big fear, right? And so just moving that, just thinking that flinging it into another data center is going to solve that. No, like Matt said, the vulnerability still exists, unfortunately, and so technology has to patch and wrap around that.
Yep, and to put things into perspective, especially for Matt here, how many radiologists? 3,500?
About, yeah.
And a lot of them, their digital footprint includes the home office, right? Their home setups. So the problem isn't just securing the perimeter of the hospital, is like you said, it's securing the systems that are being used outside of the hospital, the affiliated systems, the data handshakes between another EHR and your EHR. I mean, it's the definition of the enterprise plays a big role in how you evaluate cloud and AI for yourself. So going full circle to the main message of this presentation to you, take a step back. Don't rush into cloud or AI because everybody else is doing it. Fear of missing out can actually bring some pretty serious issues to your organization, right? The PHI breaches are very onerous. I mean, just us as a vendor, even though we've never had a breach of our technology because of how we build our own technology, as an appliance is very secure, getting an errors and emissions policy these days is virtually impossible. Yet our hospital customers require it, right? So these hackers are making life very, very difficult for all of us, not just the hospitals, but also the vendors to these hospitals. So we also have some resources online because this is a very technical, can we go back to the previous slide? If you guys want to go to this particular resource, we've put together a set of 10 recommendations for what you can do to secure your organization better from an imaging perspective, right? We're all talking about medical imaging here, not other things. And so we need to be very careful about what are those measures that we take to secure our organizations. So we put together some, these are, just to warn you, these are pretty technical considerations. So, bring them to the attention of your CTO, your CIO, or your CISO, because they will make a difference in securing your organization better than they are today. So let's do a time check. How are we doing?
Yeah, we're good. We've got about 10 minutes or so. If anybody maybe has some questions or even just comments, what you've seen around the show, we'd welcome. There's a microphone there in the center of the aisle, but we'd love to hear some feedback from you guys, what you're hearing, perspective. Also, additional resources here for anything you found relevant. A copy of this deck is available for you. Some thought leadership pieces are out there from what we've captured, so feel free, please, to visit this.
And just in case anybody was wondering, my digital footprint's about a 10.5.
It's appropriate. It's good size. Anybody that was here last year, maybe just to see if anybody wants to, feel free to not use the mic if you just want to speak up, but anybody notice the shaping and size of the AI section? It's kind of like going through, a breathing phase almost, where we see there were a lot of vendors, a lot of smaller booths last year, many AI vendors, and this year it seems to kind of have molted into a little bit of a bigger booth setup. I'm just wondering, if you guys have seen, what's your perspective on how's the adoption of AI in your mind kind of going as it relates to enterprise imaging? Is it picking up as fast as it should be, or anybody have any feedback on their experience with that?
Well, I'll cede that comment a little bit, and I've seen, reading a lot of the trade publications and a lot of the literature that's out there. I think we're clearly over the hype curve. We're clearly over the hype curve, and I just, some people, according to the adoption, it's like, okay, maybe we're not yet in the valley of despair yet or hitting that stagnation yet, but we're just over the peak of that. Mm-hmm. So it's really healthy to see a lot of the vendors in here being, multi-year contributors, that they have some longevity built into them, but there's still a lot of people coming and going. Mm-hmm. On top of that. So at some point, maybe we'll hit business consolidation, maturity, mergers, acquisition activity, see that pick up again. But it's very refreshing to see that there's still people trying.
Mm-hmm.
Questions from our audience. We love to hear from you. What are your experiences with cloud and AI, or considerations we might have not gone into in this presentation? We'd love to hear from you. No, I think we have a carbon monoxide leak in the room.
Oh, go ahead.
Yes, please. You want to come up to the mic?
Hi, so I have a specific question. If you look at few years back, when we are talking about cloud, many people were thinking like, medical data it should not be compromised and all. Nowadays, what we could see that cloud is everywhere. We are having AI. But what about cybersecurity? Because every now and then, data is getting hacked. So when you are talking about the biasness of, any algorithm or any technology that you are thinking, should you not also think first cybersecurity before applying AI?
Yeah, I think cybersecurity as it relates to AI is what Florent commented on a little bit before. There already is a surge of vendors specifically dedicated to end-to-end encryption, AI security, fingerprinting, footprinting to protect the data and monitor it from start to finish. One of the things, though, that is commonly not talked about is they identify it, they're able to kind of trap it and capture it. But what happens if it got to the point where there was an actual encryption, a lock of the data? A lot of times people forget about the return to business mode, right? With that restore capability. And so it's the whole, every good offense needs a good defense type mentality. We know that for sure. A lot of organizations do a really good job having a blueprint on how they back up, protect, and now add cybersecurity into their organization. But then they forget about, well, wait a minute, if we did happen to go down, how fast, how quickly can we restore? And that's something that's a good question. Like when it's in another environment that you don't necessarily have as much control over, how do you kind of wrap your finger around the restore capability, right? Who do you reach out to in these panic mode buttons that you need to hit when something's been identified and maybe there is data that's been compromised? If it was your own data in your own data center, your own IT team, you know how to control that and restore that. Matt can do that in the flick of his finger. But yeah, to your point, if it happens to be that it's in the cloud or somewhere else that you don't have control over, what is the implication? What are you to that vendor? What's your relationship with them in order for them to say, oh wow, you're a medical facility and you're now taken down and patient care is impacted. Let me fast track and sound the alert and make sure we get you restored or protected. Those are some of the scenarios I think that we're going to start seeing eventually. Unfortunately, I don't know how it's best handled right now, but Of course, the best thing to do right now is have a good defense, right? And have a good intrusion detection.
I'll build up, I'll add on to that. Cybersecurity now for many places is a habit. Evaluating a vendor, evaluating a service, evaluating an application, one of the first things they have to do before they're even installed is, where's your security statement? How does it work? It is now instinctual just based on the nature of how we operate on today. Some places are more disciplined at it than others. We now have working knowledge to not only understand how is it encrypted and protected in storage at rest, but also in transit over the wire. You know, are you using certificates? How complicated is your encryption algorithms? Folks are a lot more sensitive to that now these days, so there's a lot of great work that can get done up front as a part of the evaluation, and many places are putting that at the forefront of their purchasing and evaluation processes. So it's instinctual at this point.
And actually, that's an organizational issue that needs to be addressed almost at the org level in a hospital. There's not enough collaboration typically, even for some of the most sophisticated organizations out there. Don't think that it's just your facility. No matter how small or big, there are blind spots in these processes. The clinical side will request some new technology, and it'll be rushed through because Dr. So-and-so said they wanted it tomorrow, and the CISO didn't have a chance to have his team look at it, or her team. So it needs to be a collaboration at the enterprise level, right? First, you need to define what is the enterprise. Are we talking about just this building plus these other 2 buildings, this whole region of the state? Is it nationwide like Rad Partners, right? So first define the organization and then have a small committee, not a big one, but a small but important committee made up of a CTO, a CIO, a CISO, who are clinically and IT tied together, right? There needs to be more communication about how to move forward an IT organization. All these perspectives have to be taken into account before moving forward with a cloud migration, before bringing in a new AI marketplace, before before choosing a new cybersecurity partner, right? All of those things take multiple perspectives. So if your hospital or your organization doesn't have that small committee made up of technical and clinical people, it's time to actually pull it together, because they should be the ones driving the standards, driving the priorities, driving the processes that they use to scrutinize a new technology. So it really starts organizationally. It's not just a technical issue. Any other questions? Please.
Without having read your first reference over the industry standards, don't you also think that a whole lot of regulatory, financial, legal issues need to be fixed before just the technical part of it gets adopted? For instance, we still don't know how we're going to pay for all of this, right? Who gets sued if the AI makes a mistake or the radiologist does not get the AI recommendation?
There are.
Yeah, absolutely.
You're absolutely correct, and that's why I just mentioned organizationally we need to be better at scrutinizing things, but from a regulatory perspective, financial perspective, some of the blind spots include something that impacts the diagnostician directly, right? So let's say this hospital now affiliates with another hospital in the region, but there is no data sharing agreement between the two. Now you're reading images here without having the benefit of the priors available somewhere else. So you don't have a full picture of this patient's health, and that's an issue, right? So from a regulatory perspective, it's not enough to have a BAA in place. That's just the legal CYA. But beyond that, you really need to have a data handshake that actually works. But where the rubber meets the road is typically the technical organization, right? All of these regulatory, financial, legal considerations are a moot point unless they can be implemented where the rubber meets the road, and that is the IT infrastructure, right? The integration between IT infrastructures. But thank you, that's a very good point. Anyone else? Nope. Yep. Gentlemen, anything else you'd like to add for our presentation?
Thank you. Please, if you have any interest in anything that we've talked about or any other resources, just please feel free to shine your phone up there, your camera, and the QR code will pick up, and happy to speak with you. We all have our booths out there, and so we look forward to seeing you all on the show floor.
Thank you for being here, everybody.
Thank you.
Really appreciate it. Thank you.